This is June 2014, SS05, question number 2, and is an example of testing for means. Jamila is a zoology student and is researching the common toad. She decides to carry out a hypothesis test to investigate whether the mean length of female common toads is more than 1.5 centimetres greater than the mean length of male common toads. This is a slightly different question from what you can be asked. You can be asked, the most simple form of this test is where you're just asked to test whether something is bigger than the other on average. When you've got a situation like this where you're actually looking for a difference and then some, it just changes the way that we set up the hypothesis and then subsequently the test. And I'll go through that in this question. Part A asks us to state the null and alternative hypothesis for the test. I've done this in two ways. The null hypothesis is the hypothesis of no change, and the mark scheme proposes a situation that looks like that. That is, the difference between the female and the male mean lengths is 1.5. Obviously that's consistent with our test. Or what we're actually seeing, if we can find a significant result for, female lengths, when we take away male lengths, are more than 1.5. Perhaps more commonly in textbooks we use this form of the formulae, and that is that the length of the female is equal to the length of the male plus an additional 1.5, or the mean length of the female is greater than the mean length of the male plus 1.5. This is, as I say, what tends to be written in, certainly in the SS05 textbook used to support the AQA text. I've also added a little bit here that I'm going to come back to for the second part. This would then be a a one-tailed test. A one-tailed test, and the level of significance is 1%. I always find writing in, if you can get them right here, the tails gives you one less thing to think about when I come and compare this with a normal distribution, which I'm going to later on. So moving on into part B. Part B asked me then to carry out the hypothesis test. It's on the basis of 8 female common toads having a mean, so x bar for the females is 8.54, and their male counterparts have a mean length, so x bar for m, of 6.28. N is 10 because I have 10 toads here, and if I read on down through the question, all of the assumptions that I need to carry out the test are given here, that each are normally distributed and have a standard deviation of 0.6. So because I'm being given that value, that's a sigma value, 0.6. My test statistic is calculated by finding the difference in the means, 8.54, take away 6.28, but we're not just looking for the difference, we also need to account for the 1.5 value, so we want the difference, and then to allow for the fact that we consider that the females are 1.5 greater in length. Underneath is the square root of the sigma value, the standard deviation for the females, which is 0.6 squared over 10, because I've got 10 females, 0.6 squared over 10, because I also had 10, I beg your pardon, just looking back here, it was 8 female toads. So for the males it was 0.6 squared over 10, for the females it was 8. And having that different number of values there doesn't affect the test at all. So it's the difference in the means on the top, and on the bottom it's the standard deviation, which was the same for both, divided by the number that we had. It's then a case of entering these very carefully into a calculator, and the test statistic there is calculated at 2.67 if you enter those values in. Might be worth just taking the time to pause the clip here and just make sure that you can get that. We're testing this against a normal distribution. This test statistic that we're calculating here is effectively a Z test statistic. So we're going to come to table 4 to get our critical values. It's a 1% upper tail significance level, so we go to 0.99, and 2.3263 is our critical value. So if we draw a diagram, that's our 1% upper tail, 2.3263. Our test statistic of 2.67 is going to lie there, inside the critical region. So, what we're going to do on that basis is we're going to reject H0. We have sufficient evidence to reject the null hypothesis, and we will make the conclusion here, which again we should make a careful note of. We will reject the null hypothesis and conclude that it is the fact indeed that female common toads do exceed the mean length of male toads by 1.5 centimetres. And that concludes the test.